Hello everyone, welcome to Math Challenge again. Hope you are all fine. So we have 4 new questions for you from social media. Let's start. So this is our first question. It is about angles of circle. So before we start, let's remember this rule. So if you have a quadrilateral inside a square, inside a circle, so all the corners are at the perimeter of circle, then we have this rule. So this kind of quadrilaterals, we call it cyclic quadrilateral. And for these quadrilaterals, we have this angle relation. So sum of opposite angles equals 180 degrees. So according to this, then the question becomes quite easy. Sum of these two equals 180, and sum of these two equals 180. So we have two equations. If we solve these simple equations, we got y equals 60 and x equals 30 degrees. For our second question, it's about fractions with many steps. So for this kind of questions, we start from the bottom. So first, let's add these two. So if we add these two, there is one easy way. You can multiply these two and add with this one, or you can expand this 2 by 4 by multiplying both sides 4. So you can imagine this 2 as a fraction, like 2 over 1. So multiply both sides by 4. Then you will have a new fraction 8 over 4, which is exactly equal to 2. So if bottoms are same, we can add the power at the top, so 9 over 4. After you get 9 over 4, we have 1 over 9 over 4. So let's first complete this part. 1 over 9 over 4 is a division. So it is 1 divided by 9 over 4. So for the division, we change division into multiplication and we flip the fraction. So it becomes 4 over 9. After we multiply it, we get 4 over 9. So we completed this step, it becomes 4 over 9. So now in new step, we need to complete this part first. So if we add these two, we can change it into a fraction, multiply both sides by 9. So we got the new fraction 18 over 9. Since bottoms are same, so we add the tops. So we got 22 over 9. So in our final case, 11 over 22 over 9. So again, this is a division. So we can first write in division form, then we can change it into the multiplication as a rule for the fractions. So when we multiply these two, then we can simplify, or we can simplify first these two. We will get 1 over 2, and so it becomes 9 over 2. This is our third question. So the question asks which one is smaller. So we have two root expressions with different numbers and different degrees. So for this kind of questions, what we need to do, we try to equalize the degrees. So we will try to make these ones equal. Before we do that, so we change these two into the index forms. So this becomes, remember, if a number doesn't have a power, actually it is 1 and we hide it. So here there is a power 1 and here also there is a power 1. So to change this kind of expressions into the indices, we divide power of number by degree of the root. So power of number by degree of root. So the first one becomes 5 power 1 over 4, and the second one 4 power 1 over 3. So to make these two equal, we extend this one by 3 and this one by 4. So then our new powers becomes these two. So as you see, the fractions are equivalent, so we didn't change the fraction, we just extended. So in new case, if we take this power part outside, so, and same thing if we do it here, we use multiplication rule. remember, if we have two powers, we can multiply the powers. So this equals 3 over 12, and this equals 4 over 12. So we didn't change anything. We just rearrange it so we can understand which one is bigger or smaller. Now we have same powers, and let's check inside. This is 5 power 3, means 5 times 5 times 5, 125. And this is 4 power 4, means 4 times 4 times 4 times 4, so which is equal to 64. So we have two numbers. One of them is 125 power 1 over 12. Other one is 64 power 1 over 12. So in this case, the number with a bigger bottom part or bigger base is bigger because the powers are equal. So we check the bases. So this base is bigger than this base. So it means this number is bigger. So it means the first number is bigger than second number. So the smaller one is the second one. Now this is our final question for today. And in original question, we do not have this bottom part. We have just these squares and we have this semicircle. So before we start, let's remember this rule. We call this is a chord, and this is again another chord. So if two chords intersect each other, we have this rule. The rule says this times this equals this times this. So this is a very useful rule to solve this kind of questions. So if this area is 25, it means one side is 5. So since it is square, 5, 5, 5, 5. Likewise, if this area is 36, one side is 6, because 6 times 6, 36, and 5 times 5, 25. So easily we get one side of each square. Now, if we complete this into a full circle, and if we draw the other side of these squares, if you take the symmetry, and we will see that here there is a chord, and here another chord. So when we apply this rule for this chord, it is 6 times 6 equals b times this part, which is 6, 5. So this is 11 plus 8. So this is 11 plus 8. This is the first equation. And the second equation, if you check, this is a chord and this is another chord. They intersect each other. This is the intersecting point. So 5 times 5 equals a times 11 plus b. So it is the second equation. Now we have two equations. To solve these two, let's open the bracket. So 11a plus ab equals 36. This first one. 11b plus ab equals 25. Second one. Now to simplify this expression, if we subtract these two equations side by side, these ab's will cancel, and 11a minus 11b equals 36 minus 25, which is 11. And here, since 11 is common, we can factor out 11. So it becomes 11 times a minus b equals 11. So 11's canceled. A minus b is 1. A equals b plus 1. So we have a simple equation that relates a and b. Now this equation, we will substitute inside this one or this one. So as you see here, we come to here. So if we substitute 11b plus a times b, but a is b plus 1, so b plus 1. Let's open this bracket. So b squared and b, so 11b plus b squared plus b is 25. These two makes 12b, and we can move this 25 to the other side. So when we simplify, we have this simple quadratic equation. So to solve this equation, we need to know quadratics. So to solve this, you can use quadratic formula, or I complete this into a perfect square. So this is 2 times 6. So it means if we have a 6 square, it will be b plus 6 square. So I add 36 and I subtract 36. So the new case, I wrote this in this way. So now here we have a perfect square. b plus 6 squared equals, and we get this 61 to other side, 61. Now take square root of both sides, so b equals plus minus this one. Now from here, we cannot get the negative one because this is negative, this is negative. The b will be negative, but b is a length, so b cannot be negative. We will choose the positive one, which is square root 61 minus 6. So this is b, and a will be 1 more than b. So if we add plus 1, it will be negative 5. So a equals root 61 minus 5. Now the question asks, what is the radius? Radius is half of this diameter. Diameter is a plus 11 plus b. So a plus b plus 11 divided by 2 will be the radius. So a and b we have here. If we substitute, we will get 2 root 61 minus 11 plus 11 divided by 2. So 11's cancelled, and 2 root 61 divided by 2, 2's cancelled. So we got root 61 as the radius. So that's all for today. Thank you for listening. See you in our next video. Bye.